Hello, and thanks for downloading the Aerospace Testing Podcast. I'm the magazine's editor, Ben Sampson, and in this month's podcast, I'm talking to Sandro Di Natale, Product and Application Manager at test and measurement company HBK. Sandro works on static and fatigue testing, wind tunnel testing, and iron bird testing in both the aviation and space sectors. His clients include companies like Airbus, IABG, Dynetics, Embraer, Lockheed Martin, and Gulfstream. Sandro is also speaking at the Aerospace Testing Symposium in London on the 29th and 30th of September, an event which is co-located with the London to Sydney The Future of Aviation conference. For more information about either of these events, for instance, you might want to look at the programme or even register for one of them, go to symposium.aerospace-testinginternational.com or email anna.young@markallengroup.com. I'll say that again, it's symposium.aerospace-testinginternational.com or email anna.young@markallengroup.com. These are hybrid events, so even if you can't make it in person, you can still tune in online. Anyway, I hope you enjoy this talk with Sandro and find it insightful and useful. Hello Sandro, thanks for spending some time with me. Could you start a little bit by telling me about HBK and what you do and how you work with your aerospace clients?
Mm-hmm. Yeah, thanks Ben for this opportunity and thanks for introducing myself. Company HBK. We are a quite new company, so to say, but we have a long history. So we came out of a merger a few years ago from the old Brüel & Kjær and HBM, Hottinger Baldwin Messtechnik, so Danish and a German company with, so the German part is from 1950, the Danish part even older, from the 30s. Basically, if we think of an aircraft, we are working on a lot of parts there in different applications, but maybe we come to the different applications a little bit later and start with more the structural, as this is my core discipline, and the other applications are not so much my focus, so to say. So basically, if you think of a structure, it goes from coupon testing, starting from coupon testing, material testing, learning more about the material, qualifying materials, could be composites, could be metals, could also be new manufacturing methods like additive manufacturing, because you also need to qualify the same material but manufacture it in a different way, all the way up to the most interesting ones, the most interesting tests, which are the certification tests like static load test of a wing with thousands of measurement channels, thousands of strain gauges, and let's say its brother, the full-scale fatigue test. Again, you have the whole or almost the whole aircraft, could be smaller ones, business jets, but could also be the big commercial airliners like Boeing's, Airbus, and so on. And what we do there is we try to supply as much from the measurement chain as possible. So that starts from simulation software. Mm-hmm. So you have an FEM model, you have static load cases, and we're able to convert that into simulating real load. So load which an aircraft or a component, for an aircraft, it's actually not possible to simulate the whole airframe, but on component level, you have these simulated loads, which from experience try to represent the lifetime or the loads that an aircraft will encounter in its life, and try to understand, okay, where are the weak parts? Where do we later in real testing, because real testing is really expensive, so we really need to focus, where do we put sensors on? Where do we need to learn more? Where do we have critical points in the structure and so on? Mm-hmm. So we have that simulation part. And from there, we go to the sensors. Typically in the structural static and fatigue testing, that would be strain gauges, but maybe also force transducers or other sensors, to the data acquisition hardware and software. And finally, you have the data acquired. You need to understand what does that mean.
Yeah.
You need to take out the information and analyze the data.
So tell me, Sandro. I mean, I would associate the Oettinger Brüel & Kjær with hardware traditionally, with sensors and different types of sensors. How long has the company? But now you do earlier on in the process as well. You're helping with FEA and those types of simulation. How long has that been happening for? How long has the company offered those?
So I can rather speak for the HBM part of the company because that's where I come from in the HBK family.
Yeah.
Actually, that was an acquisition that HBM took around, I believe it was before I joined, but I believe it was in 2008, 2009 timeframe, so 12, 13 years ago,
Okay.
where we expanded our portfolio from what you say, being a classical data acquisition, sensor and data acquisition company, towards more into the software direction.
Mm-hmm.
I mean, I believe it's a no-brainer. Software has become more important and will become more important in the future.
Mm-hmm.
Because testing, as I said, testing time is expensive and it takes a lot of time. So people or the engineers start to or try to simulate as much as possible, of course.
So out of your clients, when do you become involved? Because your job is to kind of help clients and with the applications, is it? So are you very early on in the design phase, or do you come in a little bit later in the testing, or?
Yeah, you cannot say that in general. It depends, of course. When we enter, so depending whether we are considered for simulation, then we would enter quite early.
Mm-hmm.
I'm more a data acquisition guy, so I have deeper insight there. But there, yeah, it depends. You can enter quite early on material, coupon, or component level, or at a later stage when prototypes are already built, big prototypes, and then you enter more on the full scale level for the static or fatigue tests.
Okay. And so could you just talk me through I mean, presumably your customers, they come to you when they have a problem as well, right? A challenge. Yeah. I mean, what are the kind of common challenges that people come to you with at the moment?
So one very, very critical, and I would, if I wrote that down, I would give it 3 exclamation marks. One thing is always time, because time is money and people need to go to market as soon as possible. We're seeing quite some delays at the moment in the big commercial airliner programs, and this costs billions of euros or pounds, if you wish. And you need to think that every week, every day is very, very expensive, where you just have one prototype and you need to have that certification before you're allowed to really go into air, before you're allowed to ship that product. So that is the most pressing factor, I would say, is really time. Mm-hmm. Another aspect is, if you think of what I said in the beginning, composite materials, new manufacturing processes, pushing things closer to the limit to be more efficient in terms of performance, reducing weight, and so on. This means that our customers need deeper insights. Maybe 50 years ago, people would not care too much about the kerosene consumption of an aircraft because flying was really luxury and people would pay any price. So it was not so important. Today, it's completely different. We are all flying around the world. So we are pushing things more to the limits, not only in structural testing, but also in wind tunnels and so on. Therefore, we need deeper insights. And we believe we're an open company. So we do not say that you can or you should only use our equipment for testing. Of course, we love if you use our equipment for testing, but you're able to combine it with different ways of testing. For example, stereoscopic cameras, which give you a whole different insight compared to punctual sensors like strain gauges, which give you an excellent result on that point. But if you want to get the big picture of a wing, for example, the ideal thing is to combine these, to have the macroscopic view of the whole wing, but also the details, the critical points, which you cannot get with the resolution of a camera. And another aspect is which we have seen for quite some time, but we are obviously still seeing a lot in Europe, multinational projects. It's important that if we had a nice project with Lockheed Martin BAE Systems quite some years ago, which was a transcontinental project actually. So tests were done in the US and in the UK at the same time, and people needed to share data. And if we think of a company like Airbus, it's a European company. You have them in the UK, for example, in Filton, you have them in Hamburg, you have them in Toulouse, and they need to cooperate. Mm-hmm. They really need to work together. And our products, our solutions make that possible, both on the testing side during a test, as well as before test in simulation with a clever data management and analysis.
Okay.
So
right.
these are a few, I mean, they have a lot of challenges, of course, but these are a few which come to my mind.
Sure. Okay. And you mentioned the tool chain earlier on. Yeah. I mean, could you just define that for me exactly? Are you including all of the simulation tools and all of the kind of physical tools that an engineer has at his disposal in that? Is that?
Yeah. So we think we provide the whole tool chain for testing and data acquisition. So we're not a testing company like there are others. Maybe you know IABG, close to Munich. They have done a lot of testing for Airbus. Basically, they tested, I believe, every Airbus since 1970s, so all the A300, A320, and so on. We're not a service provider. We're more a solution or product provider.
Mhm.
And if we think of that tool chain, I define it as a tool chain for structural fatigue testing. And that starts from simulation tools. As I said, we are not a CAD company or an FEM solver company, but if you have that CAD, the data, the geometries and the load, the static loads, we can convert that into a virtual fatigue test of components. So that's where our tool chain would start. And from there, going to the physical test, including the sensors, strain gauges, including the data acquisition hardware and software to make sure that all data is acquired and at or during the test already shared with the different people, design engineers, analysis engineers, and later when it goes to deep dive evaluation, which is still a little bit separated, but obviously will be more growing together in terms of, we have a buzzword which we use for that, streamed analytics. It will grow more and more together. It will be more live analysis. We also offer that with powerful data management tools. Again, we have big teams working on that. They can collaborate, they can share data. And at the moment, we are really bringing some new stuff in terms of calculation speed. We just have, I have a nice example, again, from IABG. We were working close together with them for a customer of theirs, for an aircraft manufacturer. They had to record 180,000 flight cycles in the fatigue test. You can imagine that's a lot of data. And to perform really powerful calculations and really leverage the power that your PC or even server system has, this gives you a big advantage because it really reduces calculations maybe from half an hour a few years ago to a few minutes or even seconds. And this is where we see our tool chain. We're not into the test rig and so on, other players in the market, but this is where we define from test to report or from simulation to report.
Wait, I'm just interested. Where do you see the excuse me, the innovation at the moment? Is it more within the hardware or more within the software?
I would say the easy answer, it's more in the software, because sorry for using the buzzwords, things like artificial intelligence, machine learning, but bring that more into concrete aspects like understanding patterns, to understand if I have a certain load, how is my strain or stress response evolving over time, understanding that automatically. We cannot assess this as humans because we cannot imagine 100,000 of data points. One example, really, this artificial intelligence there, we see that as very important and will be even more important in the next years, making, again, the test engineers, the analysis engineers get more insights from the test. But nevertheless, some people might say that the hardware for acquiring strain gauges or other sensors is, at the end, it's not true. We still see ways to improve accuracy of data, reduce uncertainty of data, make the setup process, for example, more efficient, quicker, more fail-safe, and so on, really to support the test engineers who do the preparation to be more efficient and reduce time. But you're of course right. I mean, we're in now 50, 60, 70 years of data acquisition hardware. You never know. I don't know if there will be a disruptive event in the next years. If I knew, I would be really really glad. But I still see quite some room for improvement there too.
And of course, the way the software and even the simulation software itself integrates with the hardware, with the data acquisition equipment.
Yep.
I mean, that in itself is quite important, isn't it? That must be quite an important thing to HBK.
Yeah, exactly. This is what I meant with this streamed analytics.
Mm-hmm.
So the traditional way would be that you have data files. It's still not traditional. It's still the normal way today, I would say mostly. You have data files, bigger or smaller, doesn't matter, and then you take this file and do the analysis.
Mm-hmm.
In the future, and this obviously influences hardware and software, this needs to grow more together, that you really do some from a data stream directly, maybe not the fully evaluated or fully sophisticated analysis, but you already start understanding to some extent live during the test to adapt your test, adapt your simulation, and do that loop to really get a result, change the simulation, understand things better, maybe change the test, adapt the load introduction, and get better results. So this is exactly right what you're saying, Ben. They need to grow together, and this pulls requirements on hardware and software.
Okay, all right. So integrating like that would suggest that perhaps, and getting early on in the design process would suggest that test engineers need to work across the organization with other departments. I mean, is that something you agree with, and something HBK can help facilitate?
Yeah, I think so. I mean, products should not be designed for testing.
Yeah. Okay.
So I mean, for us, maybe as a data acquisition testing company, that would be great. Products should be designed for performance, efficiency, and so on.
Yeah.
But if you already consider that, and there are tools to do that, something we have in our program is the so-called virtual strain gauge, where you can already see, okay, where do I need to position that? So if you consider that as early as possible, it will pay off later, because the testing is necessary. You need to certify, you need to qualify. The authorities, FAA, EASA in Europe, they do not rely on pure simulation, maybe on component level to some extent, but not for a full-scale fatigue test. It's still a full-scale fatigue test and not a simulation. So if you consider that, it will pay off to some extent, again, in saving time during the test, I believe.
Yeah. Okay. All right. So could you just tell me a little bit? I mean, how long have you worked at HBK? 6, 7 years?
6.5 years now. Almost
6.5 years. And what's the kind of most interesting part of how you've worked with a client, or what's the most interesting application you've come across so far?
Yeah. So there are different ones. It's hard to judge. Unfortunately, that's the thing we have at the moment. Much too less. You can imagine visiting customers is really hard to tell. Hard to do. Sorry. From a size impressive perspective, I was in the hall where the A380 went through the full-scale fatigue test, the biggest aircraft ever built, these passenger aircraft, and I'm too young, so to say, to have been there during the test of the A380. But I was in the hall when there was a small business airliner, and the A220 now, the former Bombardier C series, same aircraft, of course, but different name. And you saw that during the full-scale fatigue test, still impressive, because when you stand in front of that, it's still big.
Yeah.
But you see that hall where the A380 is or was, and it seems like a toy, because the hall is so big, and there are two aircraft. They are big.
Yeah.
It's hard to transport that in words, but you stand in front of an aircraft. It's still big. Maybe seats, I don't know, 80 people, but it's very small compared to the other ones. And then if you go in other directions, wind tunnel testing is always really impressive, because it's really small scale. You cannot put a whole aircraft in a wind tunnel. It would be really incredibly expensive to have that airflow in that size. So you have a tiny model, maybe 1 to 10 or even less. But the interesting thing, and it was something I mean, it if you think about it, but I had to somehow learn. If you scale down a volume by 1 to 10 in each dimension, it's scaled down 1 to 1,000. in terms of force and so on, and drag. So this puts a lot of requirements on the accuracy of a data acquisition system. Yeah, basically you need to be 1,000 times more accurate compared to the one-to-one full-scale model. Yeah, so these are two examples.
And when you're talking about something as large as that, as an aircraft like the A380 or the 220, and then the part that HBK is helping with, it's quite small, right? But it's it's a different scale, but it's
that's
still
true.
vital. Yeah,
that's true. I mean, we all know in the test and measurement world that is not only true for us at HBK, but for other companies too. We're a niche market. We're not a 500 billion euro mass market. I don't know, like smartphones. We know we're in a niche, but that niche is important. Because if you look at a full-scale fatigue test, if you look at a static test of an aircraft wing or a wind tunnel test or something, the so-called copper bird test, where electricity is tested, when you sit on an aircraft, you rely on that. You need to be sure that the wing, when it bends, 2 meters high, doesn't happen anything. And if you know how it is tested, you know that it's absolutely not an issue, because it might have been tested to the 4 or 5 times this deflection. And it is a small role if you look at the whole project of developing and building a new aircraft. But as many others, it's not just us, but it's a crucial role, I believe, because it gives safety. It gives just a good feeling when you hop on an aircraft and you know everything was certified well. I can trust that it is working and we will not just fall off the sky.
Okay, so let's finish up now. I mean, what can we expect from HBK, and how do you think things are going to change in the next kind of 3-4 years in what you do? What are you kind of moving towards in the future?
Yeah, so this is really related to what I've been saying to some extent already. We believe that also within HBK we need to grow more together, and even have a stronger link from that simulation part over data acquisition to analysis, because we see that it might sound a little bit I don't know the English word, despective. I'm not sure if that's the word in English, but we see a new generation, a different generation of people, of young engineers, younger than I am, maybe in their 20s. They come more from the PC side, from the simulation side, and maybe you need to convince them that you still need a test. So we need to bring this together to have it really integrated, to understand, okay, simulation, test, both is very important, and you get the most out of your work when you are able to combine that as good as possible.
Yeah, because we always come to the same point. I often discuss this with people, that validation is always going to be necessary, right?
Absolutely. And if you start from the lower side, a simulation doesn't fall off heaven, and you cannot use a textbook to get a Young's modulus if you use a material which is a proprietary of your company. So on that actually, I would see tests are even increasing, because the materials, the structures are getting more complex. You need more for the simulation. You need the input from somewhere. As I said, a Young's modulus doesn't fall off heaven one day. You need to determine it, and if you make a big mistake there, let's say 10%, your simulation will be at least 10% wrong. So it's really a mix and match between data, real data, and simulated results, simulated data as well.
Good. Okay, I think that's a good place to finish, Sandro. Thanks.
Yeah.
It's really good to speak to you. Great. So some interesting insights during that talk about integration between virtual and physical testing, and how software can really complement validation phases in tests. So I'll be back next month with another podcast when I'll be talking to Norris Tai, CEO of supersonic aircraft developer Exosonic. Thanks for listening, and goodbye.